This is going to be at least a two-part video because I want to talk about blocking sessions and locking in general. Then I want to show you how to use Activity Monitor and SPHU and SPHU2 to see how to identify these. Now, at any one time, the SQL Server database engine has to manage the actions of multiple simultaneous users. Each user needs to be able to confidently select or modify data. Now, this brings up a whole set of concerns. Let's say that I connect to a database and I'm going to modify some rows in that database. And right after I grab the database, make my connection to it, and start to make those updates, you attempt to select data from that table. Should we allow you to see that data? Because you may be looking at data that's going to change any second now. And so you do a select, make a decision. Then when you go back to modify data, it's not there anymore. And there's all kind of words for these type of things like dirty reads and phantom reads and all that sort of thing. But the bottom line is SQL Server has to somehow maintain integrity so that we all see and deal with data as if we're the only person in that database. Now, the way SQL Server accomplishes this is through a process called locking. And it's the process we all learned way back in kindergarten, and that is share and be patient. Locking is managed at the transaction level, which is identified and managed at the session level. Now, in a separate video in this course, we take a quick look at what sessions are, how to identify the SPID that's used to identify a session. So if you haven't taken a look at that video yet, you may want to go spend a couple of minutes there. Now, how does locking work exactly in SQL Server? Well, notice in the SQL Server database, we've got a table called parts. Now, user A connects to SQL Server and they begin a transaction that will update a row in the parts table. There's the row that they're going to update. Now, SQL Server is immediately going to place a lock on that row. And what it's going to do is restrict anybody else from working with that row until user A completes their activity, because we know that that data may change. So user B, just a couple of seconds later, attempts to modify that very same row. Well, the lock on the row prevents user B from accessing the row. So user B is just going to get a wait state. They're just going to sit there and it's going to look like the SQL Server is slow or it's not responding. And they're going to have that wait condition until user A completes their transaction. They either commit it, saying move it into the database, or they decide not to do this transaction and everything gets rolled back. Once user A completes, either committing or rolling back, user B gets access to that row and they can do whatever it was that they came to do to that row. Now, locking is a healthy and a necessary function in most database operations. Let me just throw you a little note here and something to go read up on. In-memory tables in SQL Server never experience locking. They're taking advantage of their speed to basically just write a new row of all sorts of data modifications, and then it handles those rather intelligently when it allows you to select from that table. We're not going to go into this here. I just wanted to throw this little teaser out there. One of the reasons in-memory tables are so fast, they do not experience locking. Now let's go back to our discussion here. When locking becomes excessive, database performance really starts to suffer. Users experience blocks. That is what makes them have to sit and wait. In our earlier example, just a few seconds ago, user B was blocked by user A. So if we were looking at the session IDs or the SPIDs, we would see that one SPID was being blocked by another. And the one that's blocked just has to wait for access to the data due to that locking and being blocked. Excessive locking can be caused by a number of different situations. Number one, not enough hardware resources. If the system's just slow, then everything slows down and everybody has to wait. Inefficient physical database design. Notice I'm not saying incorrect physical database design, but inefficient. And this inefficiency can just kind of grow over time as the data grows. But if we've got a table with a lot of columns in it and a whole lot of rows, well, the chances start to go higher and higher that multiple people are going to be trying to make modifications to that one table. But if we normalize that table and we segregate the data based on relationships out into, say, 6 different smaller tables, Well, now it's entirely possible that 5 different people could be making modifications in 5 different tables, whereas before 4 of these people would be blocked and have to wait. Now, also inefficient Transact SQL programming, I'm going to show you an example of this a little bit later on, where if you build your transactions in such a way that they hang open, they stay open too long, you're going to block people. Improperly managed transactions can really wreak havoc on locking and blocking. Also, long-running queries can cause problems. So there's a lot of things that can happen that can cause locking, and it's one of the things you want to watch for. Blocking sessions or sessions that are creating locks that other people are having to wait for can be identified using 2 tools. One is Activity Monitor in SQL Server Management Studio, and then there's the SP-WHO System Stored Procedure. Also, the System-WHO System Stored Procedure can be used, and before we leave here, I'll show you an example of a newer undocumented version, SP_WHO 2. Let's just jump out into SQL Server Management Studio, and I'm going to build a little bit of a long drawn out example here, but I want you to see this. I'm going to open a query window, and I'm going to unpin this so that it moves out of the way. And we're going to work in AdventureWorks 2012. I'm going to begin what's called an explicit transaction. So I'm going to begin a transaction, and I'll just call this transaction ML. Then I'm going to update the sales.store table in the AdventureWorks 2012 database. And I'm going to set the name. Actually, let me pop down here. Let's do a quick select from the sales.store table. I'm just going to highlight that query and execute it. And notice right here, see it where it says Writers Company? We're going to change this name. So I'm going to begin a transaction. I'm going to take this out now. And I am going to set the name equal to Writers CO, we'll just abbreviate company, where name is currently equal to Writers Company. And those have to match, okay? So we want it to see Writers Company. As soon as it can find this, now SQL Server realizes, hey, wait a minute, dude, being me, is going to update this table, and they're going to change this name. What I'm going to do is execute this. Now notice I've not put in anything here about closing this transaction, not either committing it or rolling it back. I'm going to execute this, and notice it says the query executed successfully. Now I'm going to create a new second query window, and I'm going to do a little trick here. I'm going to right click on this tab and choose New Vertical Tab Group. And so this has just basically created 2 windows right next to each other. Now in this window, notice what I'm going to do. I'm going to type select asterisk from sales.store. When I execute this, I want you to watch down here at the bottom. This is running. It's still running. 7 seconds, 8 seconds. Now you see what's happening, right? This is being blocked by this. Now I want to show you something. If I go right back to here and I enter rollback tran ML, this basically means don't perform this. As soon as this executes, you will see this query show up. Notice we're now at 32 seconds. So I'm going to highlight rollback tran, going to execute that. It takes the lock away, and there's the results of my query. So you just saw locking in action. We can use Activity Monitor to see this very same situation. So I'm going to take my rollback off, and then I'm going to come over here and Control R, and I'm going to basically do the same thing again. I'm going to execute this. 1 row is affected, and then I'm going to execute this, and there's my wait again. And so what I'm going to do now is use the Activity Monitor to find this, okay? So notice in Object Explorer, I'm going to right-click the server name and choose Activity Monitor. And give it just a moment for this to wake up, and you're going to see Activity Monitor show up in its own window. Let's stop right here. This will be the end of part 1. Join me in part 2, and we'll talk about how we can see this lock in Activity Monitor.